let's look at what we have this week. So putting up on the screen our Buzz Foundations of Programming. Go to our Foundations of Programming. Look at our grade screen. This week is October 30th is due the 2.04 life development life cycle, the software development life cycle. Let's look at that lesson. We won't spend long on this today. Okay, it's just 5 pages, and page 5 is just nothing, right? So the programming process. So here's the objectives we're going to learn. All right, so read those, understand what this lesson is going to teach us. But the thing about writing really great programs is the writing part is only one step of the process. We're going to look at the whole software development life cycle process in this lesson. Let's go to page 2. As you realize, programming can get complicated. Code doesn't work, no idea why. The code works, no idea why. Sometimes we really don't know when we see that error plop up. So the software development life cycle is what we're talking about and how it's really used in programming. And let's talk about it, compare it to bicycles. This is how we're going to explain the software development life cycle. Step 1, planning and analysis. This is where you define your project goal, create a requirements document, analyze the scope of work. If this was bicycles, you'd figure out what the bike needs to work: wheels, handles, seat, gears, etc. Find out where you can buy parts and how long it will take, who's going to build it, and where you'd sell it. Okay, planning and analysis step. Step 2, design. Now you design your program by writing the pseudocode and the mock-up of how the software is going to work, what it's going to look like. We're not writing the code yet. We're writing the pseudocode. Over here, you'd sketch out your bike design, where your 2 wheels are going to go, your manual pedals, your handlebars, include your bell, your storage basket. Step 3, this is where you actually write the code, all right, or build the bicycle. Step 3, but we got 2 more steps. Testing. This is where we identify defects and debug it to make sure your software is running exactly as it's supposed to. Over here, you see if the bike actually works. Test it by pedaling slowly, quickly, make a U-turn, try out the brakes, make sure the seat's comfy, test that bell, make sure you put it in the right place, you reach it. And number 5 is maintenance, updating and making improvements based on user feedback to your program. Resolving any defects that arise. The bugs may not be there immediately. They may pop up as people input things later. And over here, your test users say they've got sticky gears or the brakes are not always working. Big problem. So you got to tweak that, go back and fix it, update the user manuals. So to learn more about the software development lifecycle, here is a different look at the 5 steps. Planning and analysis, step 1. This kicks off every software life development cycle. The team defines project goals. It creates requirements documents that outlines what do you need to build the software. Analysis, you look into the budget, the timeline, the resources, the existing technology. In other words, you plan before you do anything. Saves tons of time and a lot of wasted effort. Step 2, the design. Rather than jump right into the writing code, use this step and write the pseudocode. Helps you think through the entire process. Make sure the logic is sound. All right, it's where you provide a mock-up of what the software is going to look like, how it should work, and record everything in the program design document for future reference. Coding. Now, this is where the magic happens, right? It's where you actually sit down and write the code for the program. Once your design documents are received, then the programmer breaks the work up into chunks and starts writing the program. And as the programmer writes the code, you include comments to explain each purpose of the part. Because usually you're working with a team a lot of times, so they need to be able to see the comments and know what you were doing with this next section of code. Rather having to analyze everything, right? You have comments. Testing, step 4, right? There's always a test plan. This documents when something was tested, how it was resolved, who tested it. This eliminates all the identifiable bugs. During this step, programmers report all bugs and fix them to make sure it runs as expected. Maintenance. This is what makes the process truly a cycle. It involves continued code maintenance, checking for bugs that were initially missed, or new bugs that may pop up as the program is used. making design and functionality improvements based on user feedback, putting new requirements, user support in there. And the team documents all maintenance level work to ensure the software is operating at optimum levels. Software development models, right? People say they love music. They could mean two totally different things. One could be a diehard hip hop fan. The other's obsessed with that YouTube heartthrob turned cheesy pop icon. Right? But they both get the job done, even they do things very differently. They make their fans happy. So software development life cycles also use different methods to get the job done. Let's look at these two methods. The most common methods are known as the waterfall method or the agile method. So with the waterfall method, project teams work on one step at a time. All right, let's design the first step. So let's go through all of it until the first step is complete and working. They don't move to the next step until it's all done, completed, and approved. All right, we're all happy with this. They keep extensive documentation to keep everybody on track. They keep control of what version of the project work on, changes needed, what step of the life cycle they're in. The benefits, the process is clear from beginning to end because you are clearly defining each step before moving to the next one. The drawback is if a change is needed from a previous step, it can really delay things. You're working on step 3 and you realized back in step 1, there was something you should have put in the program that you didn't do. And step 3 cannot function properly without doing that. So you got to stop everything, go back to step 1, make the required changes. Did that affect anything in step 2? Possibly so. You may have to make modifications in step 2 before you can get back to where you were. Now, the agile method is project teams do smaller portions of the entire project in small sprints, right? They can break it up. You'll work on step 1, you 2 work on step 2, you 3 people there, you work on step 3. Teams can interact to handle different steps simultaneously if needed. And documentation is still required. In fact, it's even more important if you're all working on different stuff. The documentation allows teams to keep control over what version of the project they are working on and how the projects change along the way. So as an approach to rapid development, the focus is on the development rather than the planning, right? So you're spending more time developing, less time planning because you're trying to rapidly getting things done. But it can get confusing at times when people have to jump back and forth among the steps. So the methodology choice just depends on the type of project, as does the programming language. Some languages lend themselves more readily to rapid development, like Python or Java. They have more robust libraries or tools that offer more functionality, more flexibility. So they allow you to use, some languages allow you to reuse different parts of your code. So if you've already, I already did this earlier, I can just copy and paste it and reuse that section of code again. Makes them ideal for rapid development. It can save you a lot of time instead of having to write all the same code over again. So it's all dependent on completing all the steps in the software development life cycle. Without proper planning or testing, you can develop a project, but it'll be full of a lot of bugs. Let's look at the last page of this. When does it end? Actually, it doesn't. It's called a cycle, right? Programmers don't usually ditch projects as soon as they're out the door. Okay, I'm done with that. No, once they release it, then it's maintenance. Like you get these apps on your phone and suddenly there's an update for it. And that happens all the time. Oh, there's an update. That's because programmers have gone back and they've looked at the program and either they found a new bug or there may be an enhancement, right? There may be something, oh, well, we can add this to the program and make it better. So they go back and they write an update and they send an update out, right? So you may have the same thing on your computer for your operating system. You get an update because they've fixed some bugs or they've added some other enhancements they can do. So bugs expensive. How much was the most expensive bug? A lot. Cost $10 billion. There was a northeastern U.S. glitch that caused multiple power systems to overload. Data access caused a total blackout. People didn't have power. They had to sift through millions of lines of code to find the bug in the program that caused that. Cost upwards of $10 billion. So programmers, ongoing maintenance let programmers update their software so users can use it for a long time. And some programs are in use for years and years. So the major concerns of programmers are version control and change management, right? Because you'll get a new version of software a lot of times because they'll go through many different iterations in its life cycle. Game gets a new level. Your social media app has better messaging capability. You got to keep track of the old version and the new version, right? With this organization, it's easier to fix problems that might happen during the updates using the life cycle, all the documentation you do. Change management means programmers are keeping strong notes about what changes you need for the future, as well as the ones that have already been done. All right. This can be important when you're reviewing what you spend your time working on. So keep those things in mind. That is all of the lesson. You've got a 5-question multiple choice assignment to do this week. And that's it. It's pretty simple. So I want to keep you guys get caught up. Next week, we got the module 2 project, right? Project. It's longer. It's like 5 different. We've done programming with like 3 different sections. I think this one has 5 sections. It's going to be a longer assignment next week because instead of a test, we're doing a project. So get caught up this week. If you're behind, great time to do that. All you got is a 5-question multiple choice assignment. So it's a great chance to get caught up with any programs you haven't written that you need to get turned in and just get caught up. So we'll see you next week. I am not here Wednesday. So email me if you need something.